In the last lecture, we had talked about input and output facilities in C, and we had looked at the printf, scanf, getchar, inputchar functions. Today, we'll start looking at another very important topic, that is control statements. We are already familiar with control statements, and we have been using them in most of the programs that we have written. Statements like the if and the if-else and the while statements are what are known as control statements. Usually, program execution starts with the first statement and proceeds sequentially downwards, but in any but the most simple program, this is not sufficient, and we want the control flow to take more complicated forms. Usually, for example, we might want to do one thing or the other depending on some condition, or we might want to repeatedly execute some block of code. For that, we need what are known as control statements. We have, as I said, already seen these control statements in action and used them in all the programs that we have written so far, but we'll now in this lecture and the next lecture look at some of these statements in more detail. So there are two basic control flow statements or the control flow structures, which are, the first one is for conditional execution, which says either do this or do that. This is implemented using the if and the if-else statements that we have already seen. And the other useful kind of control structure is one of repeated execution, wherein we want to keep doing certain actions repeatedly till some condition is satisfied. So in this lecture, we'll look at the conditional execution structures in more detail. In particular, we'll look at the if, if-else statements and the switch statement, which we haven't used in programs so far. Okay, so let's look at the if statement first. In the simplest form, the if statement has the syntax shown here. There is a condition and there is a statement following it. And the meaning of this kind of a statement is that if the condition is true, then the statement is executed. If the condition evaluates to false, then the statement is not executed. There are two important points about this particular construct. First is that the statement which is shown here must be a single C statement, which means that it cannot be a sequence of several assignments, for example. Now, of course, in practice, we would like this block of code to be executed when a certain condition is satisfied to consist of more than one statement, but that is very easy to achieve because, as we have already noticed in our earlier lectures, a set of statements, if they are enclosed in braces, then that becomes a single compound statement. So this statement has to be a single statement, but of course it can be a compound statement, meaning that if we put in a sequence of statements within braces, since that constitutes a single compound statement, we can use that here. So the meaning of this statement is, first evaluate the condition. Note that the condition may have side effects, which we have already talked about, and so those side effects will happen. And finally, if the result of the condition evaluates to true, and remember that in C, true is any value which is non-zero, then the given statement is executed, otherwise it is not executed. Here is a simple example to illustrate that side effects may take place during the condition evaluation. So in this example, x is initially 0 and y is initially 1. And the if statement is if x plus plus, then y minus minus. Now, plus plus, remember, is the post increment operator, and minus minus is the post decrement operator. So when the condition, which is in this case x plus plus, is evaluated, the result of the expression is 0, which is the old value of x, and the new value of x becomes 1. So since the result of the expression evaluation is 0, which is false in C, therefore the statement y minus minus does not get executed, which means at the end of the execution of this statement, the value of x becomes 1 because of the side effect in the evaluation of the condition x plus plus, and the value of y remains 1 because y minus minus does not get executed. So let's take another somewhat more realistic example. Suppose you want to write a simple program that takes as input the marks obtained by some student in some exam out of 100 and outputs fail if the marks are less than 40. This is of course a very, very simple program. So the usual things, we declare the variable marks and read the value of marks, nothing strange here. And here is the main part of the program. If marks less than 40, then printf fail. Note that printf fail, this is a single statement, and therefore we don't really need to put it in braces to make it the body of the if statement. So when this program executes, we read the value of marks, and if the value of marks are less than 40, then this printf statement executes and fail is printed on the output. But if the marks are 40 or more, then nothing happens. No print statement is executed, and therefore there is no output from the program in that case. So that's probably not what we wanted. Suppose we want to have our program written in such a fashion that it prints pass or fail depending on whether the marks are 40 or above or not. So print pass if the marks are 40 or more, or print fail if the marks are less than 40. So in this case, what we need is an if-else statement which essentially says do this or that depending on the result of a condition. So you want to evaluate a condition, in this case whether the marks are more than 40 or more or not, and if that is true, then execute some statement, otherwise execute some other statement. This is again a statement that we have already seen in practice in many programs that we have written earlier. So here is the syntax. Here is again a condition. If and else are reserved words or keywords. If condition, statement 1, else, statement 2. Statement 1 and statement 2 again have to be single statements, but of course they can be compound statements, or indeed, as we'll see, they can themselves be control statements, like statement 1, statement 2 itself could be another if statement. So for this particular example, the code looks very simple. If marks less than 40, printf fail, else printf pass. So suppose we also want to check whether the input marks given by the user are indeed between 0 and 100, and if not, we should print invalid input. Remember, we talked about program robustness in an earlier lecture, and we should test all inputs to make sure that they have sensible values. So we want to do this, then what we need is a nested if-else structure, because the first thing we check is whether the marks are between 0 and 100. If not, then we print invalid input. Otherwise, we need to check whether the marks are less than 40 or not. So here is what the program might look like. If marks are less than 0 or marks are greater than 100, then we print invalid input. Otherwise, the code that we wrote earlier, the entire thing, if marks are less than 40, printf fail, else printf pass. Note that this entire if-else statement is a single C statement which we are using as the statement for the else part of the outer if-else statement. Now again, since this is a single C statement, we don't need to put braces around it to use it as a part of another if-else statement. Also note that the indentation makes it very clear that this if statement is within the else and this printf is within the if, which is of course within the else. So now let's take the example a little further and make it a little more complicated. Suppose you want to assign grades to students depending on their marks. So if marks are less than 40, let's say you want to give the grade F. If the marks are more than 40 but less than 50, grade D. Between 50 and 60, that is 50 or more but less than 60, then grade C. 60 or more but less than 80, then the grade B. And if 80 or more marks are obtained, then we want to give the grade A. So we might use a sequence of nested if-else statements. So if marks are less than 0 or marks are greater than 100, we print invalid input. Otherwise, now this entire thing is a single if-else statement, that is the else part, the else statement of this outer if-else statement. So this says if marks are less than 40, print the grade to be F. Else, if marks are less than 50, then print the grade D. Else, if the marks are less than 60, grade C. Else, if marks less than 80, grade B. Else, the grade is A. Now, you can see that each successive if-else statement is is the else part of the outer if-else statement. So for example, this if-else statement is part of the statement for the else part of this if-else statement, and similarly this if-else statement is the else part of the outer one, which is this one, and similarly this if-else statement is part of this entire thing. And so each of these is a single statement, and therefore we don't need braces anywhere. Also note that while execution, when we assign the grade D, we have checked that the marks are less than 50, but we haven't checked whether the marks are more than 40 or more or not. This is because we'll execute this statement only if this condition, marks less than 40, is false. That's because this is in the else part of the if-else statement whose condition is marks less than 40. This means that if we are executing this particular if-else statement, then the marks are guaranteed to be 40 or more. And of course, if we are executing any of these statements, then we know that the marks are between 0 and 100. And similarly, if we execute this if-else statement, that means that the marks must be 50 or more. And so if they are less than 60, then we give the grade C, and so on and so forth. Note that this has become a little cumbersome because the nesting level of the if-elses has become little deep. We have an if-else statement within which we have a second one, within which we have a third one, within which we have a fourth one, and within which we have a fifth one, and correspondingly the indentation is becoming more and more. Now this may make it both make the program both easier, harder to write as well as harder to read. The indentation has become quite clumsy. However, you will find that in practice such kind of nested if-else statements are quite common, and they are called actually if-else ladders. So for these if-else ladders, we prefer an alternate indentation style which is more readable, but of course conveys exactly the same thing. Let's see that in the next slide. So this is the preferred indentation style for if-else ladders, where essentially what has happened is that the if condition, if the statement which is the part of the previous else statement is written in the same line, the condition is written in the same line as the keyword else at all levels. So what has happened with this indentation style is that regardless of what is the nesting level of the if-elses, the indentation remains only at one level. And also this indentation style makes it very clear for the reader to understand that exactly one of these statements will get executed. That is, either this statement will execute, or this statement will execute, or this statement will execute, and so on and so forth. Okay, let's now consider a common problem associated with if-else statements, and that's called the dangling else problem. Let's consider the following program. If n is greater than 0, then within that, if n is equal to 0, printf n is 0, else printf n is negative. So the question I want to ask is, what will be the output of this program segment for initial values of n equal to 5 and for n is equal to minus 5? Now the answer to that will depend upon whether this else is paired with this if or with this if. So let's assume that it is the former, that is that this else is associated with this if, as indeed this indentation style suggests, because this else I have written at the same level as this if, so the indentation style suggests that this else matches with this if. So what happens if that is the case? So suppose the value of n is 5, we check whether n is greater than 0, which it is. So we execute this statement because the condition is evaluated to true. So therefore we will execute the if part of the if-else statement rather than the else part. So this is the statement that we execute. And this says if n is equal to 0, printf n is 0. Now n is not equal to 0, and so therefore this is not executed. But suppose this else were to be associated with this inner if. What would happen in that case? Now suppose again that the value of n was 5. So when we execute when we evaluate this condition, that of course evaluates to true. So we have to now execute the statement in the if part, which is now this entire if else statement. So now if n is 5, n equal to 0 evaluates to false, and therefore the else part is executed, which prints n is negative. That is, for n equal to 5, what the program prints is n is negative, which is of course probably not what we wanted. And similarly, we'll see that for n is equal to minus 5, if this else is associated with this if, then the result is not what we expect, because if n is minus 5, then we first execute this, n is greater than 0. It is not, and there is no else for this if, so nothing happens. Whereas if this else is associated with this if, then what happens is that if n is equal to 0, if n greater than 0 evaluates to false, and since there is no else part, the answer to that question will depend upon whether this else is considered by the compiler to be paired with this if or with this if. Let's consider first n is equal to 5, and let's assume that this else is paired with this if. So if that happens, what happens? If the condition n greater than 0 is evaluated, which of course evaluates to true, and then this statement gets executed, and since n is not equal to 0, nothing is printed. But suppose on the other hand, if this if happened to be associated with this if, then for the same value of n, the result will be different. So again the condition n greater than 0 will be evaluated, which evaluates to true again. And now since that is the case, this entire if else statement, which is within the if part, will be executed. Now this condition again evaluates to false because n is not equal to 0, and what executes is this printf statement, which prints on the screen that n is negative for n is equal to 5. And similarly for n is equal to minus 5, you will find, if you trace the program, that if this else is associated with the outer if, then the output is n is negative, whereas if this else is paired with the inner if, then there is no output at all. So there is an ambiguity here, because it's not clear whether this else is associated with the outer if or with the inner if. As it turns out, the C language defines that when such an ambiguity occurs or such a dangling else is there in the program, then it is always assumed to be paired with the innermost eligible if. So in the example that we just saw, regardless of how we indent it, this particular else will be assumed to be paired with the innermost if, which is this one. So which means that this program is probably not doing what we wanted to do, because for positive values of n, it actually prints n is negative, and for negative values of n, it just doesn't print anything. So if this is not what we want, as in this example, what we can do is we can use braces to tell the compiler what the correct pairing is. So if this is the pairing we want, that this else should be paired with the outer if, then what we have done is that this if statement, which doesn't have a corresponding else, we have enclosed in braces, and now there is no longer that ambiguity of a dangling else, because this else cannot possibly be associated with this if, because this if statement is entirely within this set of braces, whereas this else is outside the braces. So now the program behaves as we expect it to behave. Okay, we'll now talk about the next important condition statement, which is the switch statement, and in many cases it allows us to write programs very elegantly. We can of course do whatever the switch statement can do with if else and if else letters always, but in many cases the switch statement makes the program much more elegant and simpler to read. Essentially, when we have an expression and for different values of the expression that are known in advance, we want to perform different actions, that's where the switch statement is useful. So this is what the syntax for the switch statement is. You have keyword switch followed by an expression in brackets, followed by within curly braces. The curly braces here are essential. You have multiple cases. So case value 1, case value 2, case value n could be anything, and then a default. And for each case, you could have a block. Now this block is a sequence of statements, need not be a single statement. And the essential idea is what this statement captures is that if the value of the expression turns out to be equal to that of if the value of the expression turns out to be equal to value 1, then we want the set of statements block 1 to be executed. If it is equal to value 2, then we want the set of statements block 2 to be executed, and so on. And if the value of the expression doesn't match either of these n values, then we want this default block to be executed. But there are some subtleties in this description that I just mentioned, and we'll look at them in a minute. But before that, at the syntactic level, this expression must be of an integer type, and these values must be constant expressions. So these can't be, for example, things like x plus y, where x or y or both are variables. This has to be a value which can be evaluated at compile time. And as I said, each block need not be a single statement. It can, unlike the if-else and if statements, it can be a sequence of statements. And even if there are multiple statements in any block, there are no braces needed around the block. So let's see exactly what this statement does. First, the expression that we gave is going to be evaluated, and then it is going to be compared to value 1. Remember, of course, that the expression evaluation itself may result in some side effects, which will, of course, take immediate effect. So first, the result is compared to value 1. If it is true, if it is indeed equal to value 1, then the set of statements in block 1, block 2, up to block n, and followed with the statements in the default block, they will all be executed in that sequence. Now that seems a little unintuitive, but that has its uses, and we'll look at them. If the value of the expression is not equal to value 1, then the result is compared to value 2, and if the result is equal to value 2, then block 2, block 3, etc. are executed, again up to block n and including then finally the default block. And so on this proceeds. If the result is not equal to value 2 either, then it will be compared with value 3 and so on. And finally, if the result matches none of the values, value 1 to value n, then the default block alone will get executed. So essentially that means that if the value of the expression is equal to value 1, then block 1, block 2 up to block n, and then the default block get executed. If it is equal to value 2, then block 2, block 3 to block n, and the default block is executed. If the value is equal to value n, then block n and the default block are executed. And if the value of the expression is not equal to any of these, then only the default block is executed. But of course, usually in practice what one wants is that we want usually only block I to be executed if the value of the expression matches value I. So if we want that to happen, then we need to put a break statement at the end of block I. So whenever a break statement is encountered in any block within the switch, then the execution stops right there. Let's now see an example of the use of the switch statement, and we'll take the same example as before, that of assigning grades depending on the marks. Let's assume that we have already checked that the marks are within 0 to 100, and we want to assign the grade, and we want to do it using a switch statement instead of nested if-elses. Now note that we can't really give Boolean expressions here. We can only give a fixed constant value for each case. Now if you want to do that and use the switch statement for the grading problem, then one possibility is that we could have a case for every possible marks between 0 and 100. That is a case for marks equal to 0, case for marks equal to 1, case for marks equal to 2, and so on, up to case for marks equal to 100. And that, of course, will make the program extremely unwieldy. But fortunately, in this example, you will recall that the grade changes at multiples of 10. So the transition from the D grade to C grade happens at marks when the marks become more than 50 or 50. So we can exploit that. So if we divide the marks by 10 and then look at the various cases. If we divide the marks by 10, then the resulting value can only be between 10 and 0. So we can exploit that fact to reduce the number of cases. Now if recall that if the marks are 80 or more, then we want to assign the A grade. So if the marks are 80 or more, then the marks divided by 10, remember that marks is an integer variable and therefore marks by 10 gives us only the quotient. So if for example the marks happen to be 87, then marks by 10 will be 8. It will not be 8.7. So in these three cases, we want to assign the grade A because in these three cases the marks are at least 80 and up to 100. So in this case 10, what we have done is we have not put any statement in the corresponding block. Similarly, in case 9 we have not put any statement in the corresponding block, and in case 8 we have assigned the variable grade to A and then the break statement. So what that means is that suppose the value of marks happen to be, let's say, 95. So marks by 10 will evaluate to 9, which does not match 10, but it matches 9. So the statements in the block corresponding to case 9 will be executed. There is no statement over here, and remember that there is no break statement over here either. So which means that control falls through, as it is called, to the next case without really worrying about whether the value in the next case is equal to the value of the expression or not. So even if the value of marks by 10 is 9, this block corresponding to case 8 still gets executed because in the block for case 9 there is no break statement. So which means that the value of grade becomes A, and then there is a break statement, which means that immediately after assigning the value of grade to A, the execution of the switch statement finishes and the control comes to the next statement following the switch, which prints the value of the grade. And similarly, if the marks were exactly 100, the candidate got a perfect score, then the statements in the block corresponding to case 10 would be executed. There are no statements here, so nothing happens, and there is no break statement, so the control falls through automatically to the next case, which is case 9. Again, there are no statements to be executed here, so nothing happens, and there is no break statement, which means that the control falls through again to the next case. So grade is assigned A, and then a break happens, which means the switch statement finishes executing. And similarly, if the value of marks by 10 is 7 or 6, then we assign the grade B, which means that from marks from 60 to 79, the grade B will be assigned. If the value of marks by 10 is 5, which means that marks are between 50 and 59, then the grade is C. If the marks are between 40 and 49, the grade is D. And we don't have to have separate cases for 0 to 3. They can all be covered with the default case, because if the value of marks by 10 is not 4, 5, 6, 7, 8, 9 or 10, then it has to be 0, 1, 2 or 3, because as I said, we are assuming that we already checked that the value of marks is at least 0 and at most 100. So in the default case, which means that the value of marks by 10 is anything other than 4 to 10, which in this case will mean that it has to be between 0 and 3, the grade is F. And this break statement in the last block is not really required because there is no next block after this, so regardless of whether there is a break or not, no difference will be there in the execution. But as a good programming practice, it's a good idea to put a break statement even at the end of the last block, because if later one adds some blocks, then we might forget to add the break at that point in time. So finally, this is the end of the switch statement, and this switch statement will result in assigning the grade A to F to the variable grade, and this printf statement simply prints the grade. So this is the end of this lecture. In the next lecture, we will look at in more detail the statements, the control statements which can be used to implement loops. We have already seen the while loop in the programs that we have written. We will see more kind of loop statements and certain other statements which can alter the behavior of control flow within a loop and so on and so forth.